Hi guys, this is Madhav. I'm going to describe a quick experiment I'll show you that shows the effects of circular motion, and in particular shows how the speed at which a mass is spinning with in circular motion changes the centripetal force being generated. Let me show you my setup, which is an absolute monstrosity. I have here a big tangle of ropes. Let's see how I can show you this a little bit more neatly. So I have this string. On the left side, I have a ring attached to this little piece of yarn. In the middle, I have a pen, just like the body of a pen. You can see it's free to slide, there's no friction. And on the other side, I have a mess of more rings and some like copper wire. The key point is this is heavier than this ring. So now I'm going to take this, I'm going to use this heavier part as a weight while I hold the string like this and I spin this rope. I'm going to show you what happens when I'm spinning this light mass at a low speed, at a high speed, and at no speed. We have this mass, I'm just going to let go, no spinning speed at all. Watch what happens. Evidence, right? The mass's height. This big mass, its height is dropping. So I'm going to show you one more time. No speed. The mass's height is dropping. We'll analyze this later. Let's just see what happens. What happens when we are spinning this with a moderate speed. So I'm going to try and start spinning here. And I let go of the string. You can see the height of the mass, it's no longer dropping. The height of the mass is pretty consistent. What that's telling us is there's something now, there's some force that is opposing the force of gravity on this mass. Otherwise it would be dropping. Now I'm going to stop putting in some acceleration, with my hand here. I'm going to stop trying to spin it. Let's see what happens as the speed of this ring up here, it slows down. And what you saw down there was as the speed went down, then the mass started falling down again. So what we saw just there was some force started to oppose the force of gravity, and when the rate of spinning here, when it got smaller, that opposing force also got smaller. I'll show you this one more time. You can see pretty stable height here. At the speed that I'm spinning at, pretty stable height. I'm going to stop applying force so that this starts spinning more and more slowly. And when that happens, now the mass starts to go down. Here's the last case. What happens when I am spinning at a very high speed? You can already see that the mass, it started to go upwards. I'll try and make this a little bit more gradual. So right now, it's pretty stable. I'm going to apply more and more force. You can see relative to my finger, the mass went up. I'm going to apply less force. Mass is coming down. I'm going to stabilize it here. It's stable. I'm going to speed up the spinning. You can see it went up. Back down. Stabilize. Stable height. I'm going to increase the speed that I'm spinning with. You can see it went up. So finally, let's just analyze what went on there. So at the bottom of the string, down here, there was some force of gravity acting downwards. To keep this in the same place at the same height, we need an equal force of tension acting upwards. If we can't guarantee that, then the mass, it will slide downwards. So when the lighter mass wasn't spinning, no tension was being created. So the mass simply went downwards. When it did start spinning, it was spinning at a certain rate, remember that the centripetal force, it was trying to pull the mass inwards. And the only way that the force can be created is due to this yarn. So if we cut this, then the mass would go flying off, It would go out of its circular trajectory, just go flying off in one direction. So because of this, the tension, it was only created when there was circular motion. The tension was responsible for the circular motion. The circular motion was responsible for the tension. There was a relationship between the two that would only exist when this thing was spinning. That's why when this thing was spinning at a certain speed, you know that the centripetal force is v squared, the velocity squared, over r, the radius. So at a certain speed that this thing was spinning, the tension was exactly right so that the spinning would balance with the weight of gravity of this, large piece over here. And in that case, it would stay at a consistent height. However, when the speed started to increase and increase and increase, well, the centripetal force would need to increase and increase and increase. The issue is this mass is only so heavy. So if I'm demanding like too much, anchoring weight from the mass, well, that's just not going to be provided anymore. After I spin at a certain velocity, then this mass is actually going to be pulled upwards because the tension demanded is just too much, It is greater than the force of weight on this object. So I hope that gives you a very visual demonstration of how changing the speed of circular motion affects the centripetal force created during circular motion.